NASA's Perseverance rover was launched on July 30th, 2020. After traveling 292,526,838 miles, it landed on Mars in Jezero crater about 6.5 months later. Which of the following is closest to the rover's average interplanetary speed in miles per hour? Well, speed is equal to distance over time. So let's see, the distance is 292,526,838, and that's miles. And the time is 6.5 months. So we got to convert that to hours, right? So 6.5 months, each month approximately 30 days, because it's saying closest to, so we can approximate. Each day has 24 hours. So that would be the hours. And then you crunch out these numbers. Unfortunately, on the U.S. Math contests, you're not allowed to use a calculator. So you have to do this manually, which is brutal. But I'm sure you can, approximate this pretty closely, because this could be approximated to 30, and that would be able to cancel out with that and blah, 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 whatever. And then when you do, you get about 62,505, and the closest one is C. Figure below shows a large white circle with a number of smaller white and shaded circles in its interior. What fraction of the interior of the large white circle is shaded? Okay, so first of all, we have to figure out the area of the large circle, and its diameter would be 1, 2, 3. So it would be pi 3 squared, which is 9 pi. And then the shaded areas, we have to figure that out. Okay, so first we'll do these guys, these smaller ones, those three. And each of those has pi r squared, where r looks to me like a half. And there's three of them. So that would be the total area. So that's going to be 3 pi over 4, I believe. Okay, and then we're going to have to do this shaded area. This one right here. So let's do that. So that one you're going to figure out by first figuring out the big circle, which would be pi r squared, where the radius is 2 from here to here, minus those two smaller ones. And that's going to be the radii of 1 for, 1 each. So 1 squared like that. Okay, I'm pretty sure that's correct. So that's 4 pi minus 2 pi. So that's 2 pi. So the shaded areas are this guy and this guy. So 3 pi over 4 plus 2 pi. And then that's going to be over, because they want a fraction, so that's going to be over the total area, which is 9 pi. And this should give me the answer. So what is the answer? Let's see here. Multiply top and bottom by 4 to get a common denominator here. So that's going to be 8 pi over 4 over 9, so 1 over 9 pi. So that's going to be 11 pi over 36 pi. So that's going to be 11 over 36, because the pi's cancel. And for number 12, 11 over 36 is B. Along the route of the bicycle race, 7 water stations are evenly spaced between the start and the finish lines, as shown in the figures below. There are also 2 repair stations evenly spaced between the start and finish lines. The third water station is located 2 miles after the first repair station. How long is the race in miles? Okay, so we've got to figure this out. So how many? Let's see here. 7 water stations evenly spaced. Okay. Oh, they've even put in a couple. Okay, so let's see here. 1, 2, that's 7. 3, 4, 5, 6. Okay, so 3, 4, 5, 6. Okay, so that's pretty evenly spaced. Okay, and then did they give us anything? I don't think so. So I'll just call these X in terms of the distance. And then they tell me that the third water station is located 2 miles after the first repair station. Okay, so the repair stations are going to be evenly spaced, and there's how many repair stations? There's only 2. So Oh boy, let's see here. Let's put one here, and put one here. That's very approximate, but we'll just call that R1 and R2. So what they're saying is that the third water station is located 2 miles after the first repair station. So I guess the distance from here to here is 2 miles right there. And therefore, from start to that first repair station is our first sort of milestone or whatever. And then that represents the start to R1. And then from R1 to R2 would be the same. And then R2 to the finish would be the same. Okay, so the start to R1 looks like 3x minus 2, right? Because 3x would be all the way till here, but we have to subtract that 2 because R1 is located 2 miles 2 miles before the third repair station. So then we have to multiply this by 3 for the total distance from start to finish. Got it? But the total distance from start to finish is also 8x. 1, 2, 3, 4, 5, 6, 7, 8. So there you go. I believe that is the algebra. So let's see. This is 9x minus 6. That's 8x. So x is equal to 6. And what do they want? How long is the race? So the total distance, which is 8x, so that would be 8 times 6, and that's 48. So that means that 13 is D. Nicholas is planning to send a package to his friend Anton, who is a stamp collector. To pay for the postage, Nicholas would like to cover the package with a large number of stamps. Suppose he has a collection of 5, 10, and 25-cent stamps with exactly 20 of each type. What is the greatest number of stamps Nicholas can use to make exactly 710 in postage? All right, so we got to fiddle around with this. Let's see what happens. If I use all 25-cent stamps, that's going to be $1. If I use all 20 10-cent stamps, that's going to be another $2. And then I got to get to 710, right? So this so far is $3. So I've got to get another 410 using 25-cent stamps. Now I can't get the exact amount, but I can come close by using how many? 16? 16 times 25 is $4. Now, but I want 410. So I don't have any more coins. I've used up all the 5 cent and 10 cent. So I got to modify this a bit. Yeah. Okay. Not a problem. Let's say I use one more 25-cent coin. That would put me at 425. And then if I need to get for 710, right? So that would put me at 725. So let me bring that down by 15 cents. And I can do that by bringing the 20 down to 19 and bringing this 20 down to 19 also for the 10 cent. And I think this adds up to 710. Yeah, 95 plus 190 plus 425. So total number of coins I used was 19 plus 19 plus 17, which is 55. So the answer to number 14 is E. Viswam walks half a mile to get to school each day. His route consists of 10 city blocks of equal length, and he takes 1 minute to walk each block. Today, after walking 5 blocks, Viswam discovers he has to make a detour walking 3 blocks of equal length instead of 1 block to reach the next corner. For the time he starts his detour, at what speed in miles per hour must he walk in order to get to school at usual time? Okay. All right, so from the time he starts his detour, that's very important right there. Okay, so let's figure out how we're going to do this here. 10 city blocks, 1 minute per block. Okay. Okay, so let's take this one step at a time. We got the distance is a half a mile, right? That total distance. And then they got 10 blocks. So that means each block is 1 over 10 times a half, which is 1 over 20 miles each block in terms of its distance. And then when he does this whole detour thing, he ends up walking the equivalent of 12 blocks, right? Because it's like 1, 2, 3, 4, 5, and then 6, 7, 8, 9, 10, 11, 12. So those 12 blocks basically would be 12 times this 1 over 20, which is 12 over 20 miles in terms of its distance. And then 7 blocks is what we're talking about from the start of his detour, from the time he starts the detour. This is where he starts the detour. So it's 1, 2, 3, 4, 5, 6, 7. So the 7 blocks, that would obviously be 7 times 1 over 20. So that's 7 over 20. Okay, got it? Okay, so far so good. Now what we have to do is figure out his speed. So they're saying that they want his speed to be such that he gets to school at his usual time. Now, what is his usual time? According to the question, it takes 1 minute to walk each block. So normally, if he wasn't making a detour, he'd go from here 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes. So it'd be 5 minutes. So I got to turn that into hours. So that's 1 over 12. I just put 5 minutes in brackets here because we got to figure out in miles per hour. That's why I convert it to hours. Now, the formula is speed is equal to distance over time, but we're looking at time, so time would be distance over speed. Okay, so the distance when he's making the detour is 1, 2, 3, 4, 5, 6, 7. 7 blocks, so 7 over 20 in terms of miles. And then the speed, well, the speed is that's what we're trying to figure out. So I believe that's the equation. So that means if we cross multiply, speed would be 7 over 20 times 1 over 12, which is 7 over 20 times 1 over 12. Oh, we got to figure this out into a fraction. And it's about 4.2. So B is the answer. The letters P, Q, and R are entered into a 2020 table according to the pattern shown below. How many P's, Q's, and R's will appear in the completed table? Okay. All right, so, oh boy. I'm going to do this. Is there a shortcut? Maybe there is, but I'm just going to do it the long way just to explain it better, I guess. If I do it the short way, maybe you may not understand. So, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So what I'm doing here is counting the number of P's, Q's, and R's. P's, Q's, and R's, like that. Now, the first spot here, it doesn't really matter how you do it, if you're doing it as a row or as a column, but it's 20 by 20. So we'll just do it as, doesn't really matter, we can do it as rows. So if this is like row number 1, this is row number 2, row number 3, and so on. So the first one is PQR, PQR, right? So I'll just write it out, and we're going to go out to 20. So 1, 2, 3, 4, 5. PQR, 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 PQR. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. PQR, PQR, and then PQ. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, good. So now we're going to count. In the first row, how many P's do we have? It's going to be 7. How many Q's? 7. And how many R's? Only 6. Because there's no R at the very end, because that would be the 21st one. And very similarly, you do this for all of these guys. So this will be 6 for the second row. You do the same thing for that row, and you get 6, 7, 7. And then for the next one, you get 7, 6, 7, and so on. So I'll fill them all in. And then once you have filled them all in, now you can start counting. So for total p's, it's going to be, looks like 13 sevens and 7 sixes. So that's 133 for p's. For total q's, 14 times 7 and then 6 sixes. So that's 134. And then for r's, 13 sevens and 7 sixes, which is 133. So 133 p, 134 q's, and 133 r's. Let's see, which one does that match? C, this one right here, for number 16. A regular octahedron has 8 equilateral triangle faces with 4 faces meeting at each vertex. June will make the regular octahedron shown on the right by folding the piece of paper shown on the left. Which number face will end up right of the Q? Okay, as always, these kinds of questions, my advice is just make it. Take a piece of paper. And I'm not sure, are you allowed to use a scissors on the U.S. math exams, math contest? Maybe, but you're definitely allowed to use a ruler, so you can easily cut the shape out with a ruler. You guys know how to do that. And you just fold it up. I do not have a 3D mind. Maybe you do. And when you fold it all up, it's actually kind of cool. You'll be able to get the answer. And in this question, the answer is actually A. Number 1 somehow is the one that appears here. Greta Grasshopper sits on a long line of lily pads in a pond. From any lily pad, Greta can jump 5 pads to the right or 3 pads to the left. What is the fewest number of jumps Greta must make to reach the lily pad located 2023 pads to the right of her starting point? Okay. So how do we approach this here? So we can make jumps of 3 or 5. So we can go 5 pads to the right, or we can go 3 pads to the left. Okay, so it's actually either a +5 or a -3, and we're starting from 0, and we're trying to get to 2023. Okay. All right, let's see here. Well, if I do a whole bunch of... let's see here. If I do a whole bunch of 5s, I can eventually get to 2025, right? Multiples of 5. But then I can't get to 2023 because if I do 1 minus 3, it'll go down to 2022. So that's no good. How about if I go to 2030? If I do 2 minus 3s, I'll go down to 2024. Okay, so that's no good. How about if I keep going here? How about 2035 minus 3 minus 3? Yeah, minus 12. That would bring me down to 2023. Okay, so for this, I did 2035 divided by 5 moves. So that's 407. And then for this guy, it was 4 moves of each being minus 3. So that's 4 moves. So 411 is 407 plus 4. I think that's the fewest you can do. I'm pretty sure about that. So that would mean that D is the right answer. An equilateral triangle is placed inside a larger equilateral triangle so that the region between them can be divided into 3 congruent trapezoids as shown below. The side length of inner triangle is 2/3 the side length of the larger triangle. What is the ratio of the area of one trapezoid to the area of the inner triangle? Okay, so from here to here, we'll call that, I'm just going to actually give it some numbers because they're looking at the end for a ratio, so it won't matter. I was going to initially use X, but I like using numbers better. So I've called this 6, and then therefore this would be 9 because it's 2/3. Now, the area of an equilateral triangle, it's helpful to know the formula. √3/4 times a squared, where a is the side length. So the area of the inner triangle would therefore be √3/4 6 squared, right? Which is 36 root 3 over 4, or 9 root 3. Yeah. So we got part of it, ratio of the area of one trapezoid, so over the area of the inner triangle. So we got that part. We just have to figure out now the area of one inner trapezoid. Okay, so one inner trapezoid. I think how I do it is I find the area of the large triangle minus the inner triangle, and then divide by 3. That would be how I get the area of one inner trapezoid. So the large triangle is root 3 over 4, 9 squared. The inner triangle, well, we already did that. That's 9 root 3. And then divide by 3. So this looks like 81 root 3 over 4 minus 9 root 3 over 3. So give this common denominator. So that's going to be 81 minus 36 root 3, which I believe is 45 root 3. And that's over 4. And then time this 1/3. So this is going to be 15 root 3 over 4, I believe. Right? Okay, so that's what goes up here. 15 root 3 over 4. Okay, so let's do this. 15 root 3 over 4. Invert and multiply. 1 over 9 root 3. And then this becomes, the root 3's cancel, so 15 over 36. 15 over 36, which is 5 over 12. So there you go. C is the answer to number 19. Two integers are inserted into the list 3, 3, 8, 11, and 28 to double its range. The mode and median remain unchanged. What is the maximum possible sum of the two additional numbers? So 3, 3, 8, 11, and 28. Now you want to double its range. So first of all, what is the range initially? The range is from 3 to 28, which is 25. So we want to double the range, so we want to make the range 50. Okay? That's what we want to do. And we want to keep the mode and the median unchanged. The mode is 3, so we want to make sure that 3 remains the mode. And the median is 8, so we want to make sure the median remains 8. So we got to put in two numbers somewhere to meet all these conditions. Okay, let's experiment here. Let's see here. If I put in a 7, I can't put in let's see here. One number has to be to the left and one number has to be to the right of that 8. That's the only way the median will remain unchanged. And I cannot put an 8 or an 11 or a 28 because that would make the mode, it would make it a tie with 3. And I also can't make a 3. Well, I could actually make a 3 because that would keep the mode as 3. Well, let's start somewhere. Let's start with a 7. If I put a 7 here, then in order for the range is still going to be 3 to something. 3 to something, and that's got to give a range of 50. So this is got to be 53. So here we got to put a 53. Okay, now let's see if my other conditions have been matched. Is the mode still 3? Yes, that's the number that appears the most. And the median is still 8. So what is the sum of the two additional numbers? Well, the two additional numbers that I wrote were 7 and 53, so the sum is 60, and that's the maximum. I think that's the maximum because I purposely went as close to 8 as possible. I can do other numbers, right? I could put a 6 or a 5, but then that would make the number smaller. These two numbers would be smaller, and therefore they would be smaller than the 60 sum. So I'm pretty sure that's the answer, and that would be D.